pick it up as we go. So Oscar is going to be mainly focused on answering your questions in the chat while I'm talking, because I just don't want to lose any rhythm here and making sure that we get through all the information we want to share with you today. So if you're sending anything in the chat, you can say hi to Oscar specifically, be like, Oscar, can you tell me? And if it's something that I need to get back to you about, I'll be looking at it at the end, and I'll be happy to follow up with anybody. So welcome, everybody. We are Thimble, and I'm just going to jump right in here with what is our goal today. I've already made the comment, right? I've been a teacher for 13 years of my life, and everything's always about what's your objective. And our goal today, so we had a very high rate of responses from our June session of people who wanted more close look at what it's like teaching with Thimble. And the goal we wanted today was to really give you what's that Thimble learner experience, and how do we focus on reaching students with tech projects, and how do we support teachers in that process of spreading tech education. So as we're just kicking things off here, that's what we hope you'll leave with today, is a really strong view of what that experience is for your students and how it's going to work for you. And I believe, and I'll tell a little story about this, it's important to have content from a vendor that makes it so that even you as a first timer can be successful. And so this is not about going to engineering teachers and saying, here's this really great product, it's a robot and it's $10,000 and your students will love it. That's not for everybody. This is about practical, real world, accessible product and experience for your students. We're really focused on accessibility for you and your students, because some of you out there, and I got stories about that chapter in my life of next year, you're the STEM teacher. And, or friends of mine who were a librarian one year and head of the makerspace the next year. And, we really want to make you feel like what Thimble brings and in how we design products is focused on supporting you in those moments in your life and in your teaching. So our priority is to show you what I express as behind the curtain. What really happens behind a Thimble lesson? How is it structured? And how does it support you and your learners? So my favorite teacher in college, his name was Martin Cockcroft. He was an English teacher. And after class, he would tell me how he planned his lessons. And he would tell me stories about things he did when he student taught. And he would tell me all kinds of things, just genuinely mentor-like advice about being a teacher. He did not work in the education department. Instead, he worked in the English department, and I had him for literature classes and creative writing classes. And I personally felt like this was the most useful stuff I got, was things like, well, my number one goal today was to get people involved in what it's like to discuss literature. So I came in with, this strategy of just getting people talking first and then bringing up questions about literature. And then they didn't even realize that we went from just, how was your weekend, to talking about literature. And I was like, that's really smart, right? Because if you make it straight to the content, people are intimidated to speak up in class. The quietest person doesn't want to say anything because it might not feel comfortable. But if you just say, how was your weekend? Or how was your, whatever break we just came back from? I was like, that's a really great suggestion. That behind the curtain glimpse is our goal today. We want you to feel like you got that look at what we were doing in June about design thinking and what we do across all of our content. So if you were in our session in June, great. If you were not, I'm going to put the chat. I'm going to put in the chat here a link to the YouTube for it. I'm just going to take a quick check here. Again, I'm primarily just looking at the presentation here, and I'll be happy to follow people at the end, talk with you. But yeah, the video link there is the presentation from June. I'm going to recap the most important slides from it for about 5-10 minutes. Just because it sets up why we're here today. But if you weren't able to see it in June and you would love to hear more about design thinking as I'll just jump to the slide here. It's a 5-step process similar to the engineering design process. I equate it to, if you've never taught anything like this, think of the scientific method, where you go through the whole steps of, making a hypothesis and all those steps that you're familiar with in science class, right? We do the same kind of thing in engineering. But design thinking is focused on defining your problem. Starts with empathize with your user, define the problem. Ideate is for generating your solutions, prototype, test, and then essentially go through like a cycle of doing that again and again and again. And that's design thinking, right? That's how we refine a product. That's how products continue to go through iterations and so forth. So this is a big opportunity right now in engineering and in tech classes, because we're all, looking to follow through on the promise of social emotional learning in the classroom. And design thinking brings that element of empathy. So if you haven't gotten excited about design thinking as an opportunity for your students, and your district is talking a lot about social emotional learning, I know my district's talked about it for years now, and we all recognize, especially as we are helping students who have had a lot of life changes through the pandemic years, social emotional learning is key, right? So getting people to empathize as part of a school project of just looking at things through other people's eyes, is helping build that social emotional skill set for our students. So there's a lot of value behind these kinds of things, right? So let's go ahead and I'll just, like I said, kind of recap a little bit of what was in our June meeting. It is in the chat for anybody who, and I'll post it again at the end if anybody signs in throughout the time period that we're here and maybe misses getting the link in the chat there. So the big thing that I think was important about that presentation in June was about connecting with students at an accessible level. The expression I use a lot is that when you look at news media and we celebrate only these CEOs of enormous tech companies, that's actually a really narrow chunk of the tech careers, right? Like not everybody works for SpaceX, not everybody works for Apple, not everybody works for Google. I'm in the Pittsburgh, Pennsylvania region, right? So if you're familiar with the Pittsburgh Steelers, right, you know where I am, right? I'm 40 minutes outside of the city. Duolingo, the language learning software, is headquartered in Pittsburgh and has an enormous number of tech professionals. I've seen the CEO of Duolingo speak, and they're actually doing a Duolingo Con or something like that this month, I think, where he'll be speaking to all of the Duolingo's users. But I've seen him speak for education stuff local here in Pennsylvania, right? And I think Duolingo is a phenomenal example of tech companies that are not Apple, not Google, not Elon Musk talking about all of his companies, that students can very realistically have their eyes open to. Every software product has people developing, whether it's Duolingo or it's, the people who if you use Slack in your school for planning, or Trello or other things like that, or Discord, all those tools, our students use that, right? You don't have students using Discord, you just haven't heard them talk about it yet. Software developers work on those, right? So I think it's important that students see that other part of the world, right? That is the everyday software utilities that we use, the everyday electronics that we use, and the companies that do those things. I visit the local machine shops in my area. There's a local machine shop that builds things for Tyson Chicken, and it's like a small little machine shop in Western Pennsylvania that nobody would ever hear of, but they're building things that go to Tyson Chicken farms and other agricultural industry stuff, right? And so it's important when the students see that other part of the industry, because they're all running around saying, I'm going to work for Microsoft, I'm going to work for Apple, and the reality of it is there's many careers. Maybe that's not really what you want to do. Maybe that it's just because that's the only thing you really ever heard of. So I'd like to focus on design thinking stories that are from everyday objects, relatable to everybody. So this is probably the most important thing that I tried to pitch in June, was be more accessible. Don't just talk about things you see in the news. Look for accessible stories everywhere. And I shared a few of these. The biggest one in the June presentation was probably the amount of slides I dedicated to Tide to Go stain remover pens, which is not going to be today's topic, but I will tell you that it's a good reason to check out the video link if you didn't see the June presentation. The ones that I really use probably across many grade levels and throughout the year is simple stuff like talking about chapstick packaging. Because if you walk into a Walmart, this is not at every store, because like Target, for example, doesn't bother selling the lower tag priced single unit chapstick on a hanging peg, but Walmart does. You'll see that the single stick chapstick hanging peg product packaging is packaged in 2 different lengths, so they can nest twice as many products on a peg. Now, an engineer came up with that, a packaging engineer. that they said, here's our cost per peg to have space in a retail setting. Here's our package. How do we maximize value for our customers? So we need to, reduce our cost to fit, let's say 30 sticks on a peg, which might be 2 pegs. Let's bring it down to 1 peg and fit 30 sticks where we used to fit 15. Packaging engineer looks at this, says, well, this is not like a package that needs to really be this much of a footprint. It has only a bump at the bottom. Why don't we nest 2 of them or even 3 of them? We'll make different length packages. Packaging engineer solves this. If you ask your students, do you want to be a packaging engineer? Many of them will say, what is that? I have one student whose dad is a packaging engineer. And I had a conversation with him. He was like, well, yeah, I never really thought about like the fact that that's not something people usually see, because I grew up with it. And I was like, but it's really special. Nike has packaging engineers who, deal with their product line. How many students out there that, want to be an engineer, think they only want to work for SpaceX and Tesla and all these things? And you say to them, what about Nike? It's like, Nike's fashion, but Nike's engineering. Even just their shoe tech is engineering. Now, Oreos, I used this example in June as well about iterative design, talking about going from regular stuff to double stuff Oreo. If you observe how people interact with Oreos, you realize that they always, want more filling. So they've iterated Oreos, they've made regular stuff, double stuff, mega stuff, most stuff, and many other things in between. I actually make a point to, I always have like a wealth of Oreo boxes or packages to show my students different Oreo configurations. There's seasonal ones every year that just continue to amaze me. Like they once had a Lady Gaga flavor Oreo, and I thought to myself, I was like, wow, Nabisco is really into innovation. So you want to model design thinking. You want to find these stories. You want to be relatable to your students. And the story I shared in June about modeling design thinking was actually about creating a dice simulator. So I'm going to jump into what that is. So it started with understanding a problem from an empathy standpoint. The story was really simple. I'll talk about it here. You want to have a story that centers around people. You want to prototype something, and you want to be able to, define like metrics of success. Oh, okay, well, it solved this problem, yes or no? And how did it solve it? How well did it solve it? Could it solve it better? So you want to create that experience for your students, because if you just hand them the design thinking process, like how many of you, if I said empathize, define, ideate, prototype, test, go. I mean, like that's not really a good way of teaching. That's not education. That's just listing stuff, right? So we have a story. We want to create an experience for students. So the story that I had in June, and again, I got only maybe 2 more slides recapping June, and we'll again, I'm kind of presenting it totally differently than in June, because I'm really talking more about why we do this, how this is beneficial. And I want to talk about how we do this at Thimble with our products, and how you can do this even with everything you do in your classroom. So Settlers of Catan was the example I used because, if you throw your dice in the middle of this board, you will hit game pieces. And the game piece locations matter. And, you shouldn't throw your dice on the board. It's also the same problem in Monopoly and other games, right? So the idea was, let's build a dice simulator. I've already solved this one, but first we would learn about how do you make random numbers, which is a coding skill. Random numbers are actually a 2-step process. It's not as simple as just saying, give me random numbers. Whenever you're generating random numbers in computer science are actually a really tricky problem. They describe them as pseudo-random. There's a random number list in the resources that your code pulls from. And if you just point to that random number list, it starts at the beginning. And it's really a fascinating little piece of code magic here. There's a line of code that creates a random seed. This is really a cool thing if you're into tech stuff, that it will take a random environmental reading and it locates itself somewhere in the middle of that pseudo-random list of numbers. You don't need to worry about those details. That would be what you would be teaching, and we have slides that explain that. But I guess my point being is that we would cover that as a whole part of the experience. Then we would make dice rolls. Then we would work towards, and I'm going to switch my camera now to my desk and I'll show you the end product. And this is what we looked at in June, which was, how do you, experience this? And so there's a little screen here, and here, let me go ahead and make sure that and it tells you, how many dice you're going to roll, and this dial is the selector for how many dice. So 1 through 8 based on the game. So we'll do 2, and then this push button here. And what's cool is like these little pieces, right? Students can take these and actually attach them to like a cardboard board because they have little screw mounts. They could, actually like build this into a mock-up of like a product, right? So I actually bumped the button there. So it says press to roll 2. I click the button and my random outcomes show up. And it says press to reset, and I click again and it goes back to blank, and then I can pick, right? So that was the design thinking story from June. All right. So let's go back to my slides here. Switch my video back to me. All right, so that's the story, design thinking. And what we talked about in June and what we think we really want to help you with today is to understand crafting these experiences. You have to look at what is it you're trying to do? What do you feel like are the teachable pieces, right? I want to teach about random numbers, which I already told you is a really fascinating topic. Wouldn't worry about it today if you're sitting there going like, I don't know the nuances of how random numbers are generated in computer science, but you would get the slides and resources there with the Thimble content that we have. What's a loop of instructions? That's a code that repeats for either a fixed number of times or for until a certain condition is met. What are the different types of inputs? You saw that I had a dial that I selected how many dice to roll, and I had a button to start it. And then there's this thing called conditionals that is like, if this is true, do these things, and so forth. All of those are code pieces of content that are being taught through this project. So they're all taught individually with the content that we provide. When June, we really only showed the end result. So today I'm going to pull up what that looks like and talk about like, this is what a real Thimble lesson for students looks like. This is what we teach with. These are the resources we provide. So those are things I want to teach. Well, there's actually several games and outcomes that we've developed at Thimble that do those projects. We have a Magic 8-Ball project we've done with students. We've done a dice simulator. We've done a heads and tails game simulator. They're all built around random outcomes. And they have different ways of working. So this is I've just changed my tab here to show you, this is the content that you would use teaching about Dice Simulator. Now, this is like halfway through our program. I jumped in midway because it's going to give you a better view that you got to deal with, right? Students that enroll middle of the year, right? What do you get? So the agenda here shows you that we're going to start with, how does an LCD screen work, that little screen? And then we're going to work towards making a dice simulator. We have this sort of hidden structure, and I'll go back to my other slides in just a moment here, but I want to show you that, we always review what we left from the last project, like what was the big takeaway, right? And we always give clear instructions on what materials we're using. And we always break down something about those materials in a practical way, getting students to talk about what are LCD screens. Okay, well, an LCD screen is actually something that we encounter all the time. We use, liquid crystal displays on regular everyday devices. Now you might be like, well, there's OLED and there's other, screen tech. What about plasma TVs? I don't know if anybody even buys plasma TVs anymore because, they're been outpaced by other tech. But anyways, just talking about how screens work. And let's talk about what do you know about displays? This is the part where you connect with the students. This is what a Thimble lesson looks like. Now, I'm not going to do this like as if you're because this is multiple hours worth of content I'm going to show you here, but you want students to really look at like where are screens in your life? Televisions, computer monitors, phones, smart watches. They're all pixel-based XY coordinate planes. And that's what we, then dive into. And the thing that is on this slide, lower right here of this slide, is that 0, 0, the origin on an LCD screen, is actually the top left. So here we now connect it to things students know. When you're graphing, 0, 0 is the bottom left. And whenever you are actually doing LCD screens, it's more like Battleship, where it starts in the top left, which Battleship, ironically, like I'm a big prop teacher. I got a old copy of Battleship upstairs that is probably from the 80s and has like, you know how like the lids on cardboard boxes for games, you know, would rip on the corners, and like they have like basically, you know, like a flap side of edge to them now. Like it's that battered. But you know, I love pulling up Battleship to show you know, students that, you know, the origins top left. So instead of it being A through J and 1 through 10, right? You know, we actually go 0, 0 at the top corner, and then it builds out. So when they learn to code, talking to this LCD screen, they actually set the location for the outcome as 0, 0. So this is the LCD screen, and this is an alphanumeric display, which is a little different than addressing every individual pixel. Is it's more like a calculator screen where every single character takes up the same fixed amount of space, and you know, here's the numbering. Now, if you're looking at these slides and thinking, you know, like, could I present this? Would I be able to teach this? Let me get out of presenter view and show you. This is how we provide information to our teachers. Do you see that I have notes at the bottom? The key detail to remember is using a formula to change dial readings. So the previous lesson was on dial readings. So when you reach the review slide, it says, you know, this is what you want to remind your students about. You know, our goal is to make this accessible for first-time teachers, right? So whenever is something tricky, or whenever there's links. So this is where code is for students to then go and upload to their board. You know, we provide the shortened link, so if you're presenting your slides, the students can easily type it in, right? And then we provide the full link for you in the notes. And this one's probably not a great example of me adding in little notes to people, but oh, here we go. If there's something where you should actually be doing, you know, a certain task, I give little reminders, you know, and I can say that every single one of these, if there's something special, this one doesn't have a ton of special things because we try to put the maximum amount of stuff possible on every slide. You can see this is a very large amount of slides for teaching several steps of content, right? Everything down to where do you place each piece, you know, with very easy to follow visual diagrams. Let me go to one of the other ones here and see if I have another example of putting in extra notes for people. So here it is again, key detail to remember, remind them about LCD grids, right? And things like this. This is a different lesson altogether. But anytime there's something that I'm worried about clarity for teachers, I always put it in the notes. If there's something that I'm worried about, or if there's links, you know, you can count on when you get this content, right? You know, that we build it. I'm just going through a couple lessons. There we go. This is an upcoming topic through these slides. The buzzer's a vibrating disc that moves when energized, and code can make it move at different speeds and make different sounds. All right. So if there's something that we ever feel is like not clear on the slides, you'll always find it in the notes, right? So that's part of how we build our content. So back to the pacing on this here. So you get this info about how to, you know, the LCD screens work, and, you know, we give quick checks, things like make sure your board is in the right configuration, place your parts, here's the code, right? And then we go through, this is something you won't find from a lot of computer science vendors. And I've worked in online education for 13 years. So when I say I'm a teacher, I'm not only worked with students, but I've worked specifically in an environment that's heavily vendor based. So you get a lot of, so like in online learning, you know, a lot of our programs are purchased from vendors, right? Because there have to be all these digital assets. I've seen content from a lot of other places where they don't break down the code in a way that kids really get what they need, right? So I'm gonna go ahead and full screen this back again to presenter view. I just want to talk about what we do at Thimble and why it's important. So the code that the kids uploaded to their board was here. This was the code. Unless you're a really good coding teacher, you're just copying and pasting and hoping that nobody asks you, what is this line for? That's what happens, right? I've met those teachers and they teach computer science related stuff, and they literally like just have to blind faith trust that anything they copy and paste is going to work. We don't want you to feel that way at Thimble, that you have to just blindly trust that it's going to work. And if there's a problem, you have no clue what any of the lines of code do. That's not teaching, that's not education, that's not growth, right? So we break it down. These lines specifically, you can see I have a little explanation, set the color values for red, green, and blue, because a display like this is actually backlit with 3 colors, red, green, and blue. You can actually change the color background. So 128, 128, 128. This is actually covered in another lesson as well. You can customize the colors. We don't do it in this particular lesson, but it is something that we do. The next part here says, this sets the size. What is the grid size? It's 2 rows, 16 columns. So 16 wide, 2 tall. Would you know that? LCD.begin, parentheses, 16, 2. If you're looking at this slide and a kid says, what's LCD begin for? I don't know. Thimble's going to tell you, and we're always going to tell you, because our agenda is to help you become very good at computer science and teaching kids tech while your students experience learning this as well. And you can see that, again, we have every piece of this content explained. And then I talk more about LCD screens and how LCD screens refresh and creating efficient code that only replaces text when we need to. And that's the next part of this, and it goes down to, that's how granular we focus on making you, really well-versed in tech stuff. Did you even know screens have refresh rates? Did you even know that, like you want to create efficient software that only, refreshes something if it needs to, like, especially when you're working on a device that like Arduino based boards, what we do at Thimble. And this is a whole interesting kind of thing. When you talk about the strength of the processors in them versus the strength of processors in smartphones and computers, they're worlds different. They're not ultra powerful, right? Because these are what you would consider embedded electronics devices, right? So they're not the kind of processor structure that you see in a smartphone, for example. So efficiency is key, right? Which for anybody who's ever had a computer science experience where you had a teacher who talks about like when they had to write things in punch cards and other old-fashioned tools, efficiency has always been key in software, right? So we go through all these steps, right? And we highlight where we want to draw your attention to. And that's how we make sure, that when you're teaching this, right, again, what does the code do? We never leave you hanging on wondering what things are, okay? So that's how we build our lessons. So the Thimble Learner experience, which you just saw firsthand, is actually behind the scenes structured around a very simple set of principles. We want to help every level learner. Are your students beginners? In many cases, especially because if you've taught Hour of Code, if you've, bought other products for your classroom, right? The wealth of stuff out there to get kids started, so many choices. The range of options to get kids up the staircase towards, advanced level user, minimal options. There are tons of Hour of Code style products out there. That 1 hour introduction, get kids excited about coding. And there are not a lot of things that actually like dive in line by line. What are you actually writing when you write code? How does it work? What are these components in the robot kit? I love Sphero robots because they get kids excited about, like if you've ever done a Sphero robot activity, this little ball robot, you maybe make, mini golf courses, and the kids, steer it like a golf ball, and they make their own little mini golf course, they make race tracks, whatever. That's fun, right? But like Sphere Robot is built on a bunch of really basic electronics that are in everything. It's like the DNA of all electronics, right? They all use, tilt sensors. It's in your watch, it's in your phone. They all use, LEDs and all kinds of stuff. And it's a great way to get kids excited, but, you don't really get to build the Sphero robot. I know they have a more advanced bot that, does offer more coding capabilities, but you get where I'm going with this, that like there are a lot of introductory things out there that serve a certain audience. We're really concerned about how do you get people climbing that staircase from beginner to intermediate to advanced, and how do you go up that staircase with them? And you have students who are already at the top of that staircase. How do you, as a beginning teacher, give that student an experience that they actually still value, right? We've all had that student who raises their hand and goes off for 5 minutes on something that is over everyone's head, right? And they almost intentionally want to push you out of your comfort zone, right? They thrive on challenging that teacher. we don't want to dismiss that student. We don't want to discourage that student because they're passionate, right? How do we make learning experiences that welcome that advanced student and welcome that beginner? And I'll talk a bit more about that here. So you're a newcomer to tech or you're experienced in tech. Your students are newcomers or they're experienced. How do you serve the diverse range of learners? And we do it this way at Thimble. So if you looked at what I was flipping through on the slides, if you were able to see where I started talking about just the basics of the XYZ grid of the LCD screen, that's the fundamental concept we want you to get that day. You saw me show off though this dice roll simulator thing. That's the project, that's the challenge level thing that we want students to get from doing a Thimble lesson, right? So we call it fundamental project challenge. So actually, I'm going to go back to the dice simulator one and scroll through more of this to show you that the end of it here is an enormous amount of code, right? But we highlight where all the fundamentals are because your beginner student is going to walk away understanding 40% of this code. Your advanced student will walk away understanding 100% of the code. So here's the project that uses the fundamental of how do screens work. And all the things that are highlighted, you'll see they have XY coordinates in them, or they have a range for random numbers, right? So we're either pointing to relocating the cursor, meaning start where the text displays at 0, 0, or 0, 1, meaning the second row, and then the random number stuff. So this one's fundamentals were about XY coordinates on screen, random outcomes, and button presses. We really weren't worried about people understanding how to change the color of the background. We weren't worried about people understanding this is not the lesson that focuses on looping structures necessarily. We have that in other lessons. So we call out what should your beginner student actually get from this lesson. And we've plotted these purposely so that as you go through every lesson, you start filling in all of these gaps so that you start understanding the whole page. Again, different than what you'll see from other vendors. So then we go on to say, and here's a challenge for you, an advanced application of that fundamental, an enhancement on that project, right? And this is where we actually add the ability for, so the original project is a single dice roll outcome. And if you watched when I showed my desk earlier, I allowed you to spin a dial and select multiple dice, 1 through 8. That's the most advanced version of this project. And we call it the challenge, right? And then it ends, here with the challenge, right? How's it solved? So we build every experience. So every project your students are going to do starts with all the way down to what are the XY coordinates on the LCD screen or whatever basic fundamentals the goal of that project. Then we do the project and then we enhance the project with a challenge level. So your beginner will get fundamental and about 40% of the project code will make sense to them. Your intermediate user will get the fundamental and they'll understand about 100% of the project code. Your advanced user will understand the fundamental, 100% of the project code, and be able to do the challenge. Got it? So this is how we account for the fact that tech, there are a lot of inequalities in tech. Did you have, like I said, about how a student whose dad was a packaging engineer, so to him, the idea of designing things that fit together and stuff like that was normal. The idea that there's packaging engineers is normal. It's like, I have a lot of students that, their parents do not work in tech. How do we bridge those gaps, right? So, so here I've talked a lot about people at all different skill levels. I think it's important for me to point out, I'm one of those people who did not start in STEM. This is my actual teaching certificate, and it is my 2009 teaching certificate as an English 7 through 12 teacher. I made it till about 2012. So 2009 to 2012. Before I basically was never going to use that English teaching cert ever again. I had 3 years of value out of being certified as an English teacher. And then I was that newcomer to STEM education who was like, yeah, this whole STEM thing, like, can you picture 2012 if you were a teacher back then? Like, the STEM acronym was still like, what do those letters stand for? And people were changing it up. It was like, well, we do STEAM here. What's STEAM? Oh, well, we added arts, or STREAM was my favorite. We added research, we added an R. And I think I saw once upon a time it was called STEM plus M. So it was STEM with a second M. And it's like, we added medicine. I was like, people just want letters, man. They don't care about anything else they're doing. But I was a newcomer to STEM education. So this fundamental project challenge thing, which I gave you a little bit of breakdown just a moment ago, I'm going to put it down again here, and I'm going to show you an example of how we build this project. or these projects around this, okay? So fundamentals always accessible to an incoming learner. Projects can have some unfamiliar content, but showcase the fundamental. And the challenge is based on the same fundamental, but relies on broader knowledge. So this is where beginner, intermediate, advanced users all have some part of that lesson intended for them. So it starts like this fundamental. What's an LED? Maybe you know what an LED is. Maybe you can see my little thumbnail of me on the video. I'm gonna hold up a little LED. It's a little dome-shaped light, okay? How do you make it blink? If you get that one basic thing, bingo, you've grown. You've grown your skills. You have growth. You've succeeded as a teacher. If that kid who's never even said they know what the letters LED stand for now knows it's light emitting diode, right? Now knows that home lighting is rapidly transitioning to LED. If people are still using CFL bulbs, I don't know why, because they're hazardous to the environment. LED bulbs are, a much better solution finally. I was buying LED bulbs when they were really overpriced. I'm thrilled now that I can buy them at dollar stores now. I think they're a phenomenal product. But our students, they just think of them as light bulbs, right? Let's show them, right? So I'm going to switch to my, I'm turning off my slides here for a second. I think I mentioned before, I love using props, right? It's a big part of how I do my class, right? Sorry, 1 second there. Clicked in the wrong spot there. All right, got what I want. So hopefully you can see me nice and big here. And I take my dead LED bulbs and wear a lot of safety equipment when I do this because it throws plastic everywhere. And I cut half the dome off to show my students the actual LEDs inside. Many of them are stunned to find that, because LEDs don't give off that much light. Much like how an LED flashlight, which do I have one nearby? I'm always looking for props around to show people. I could have sworn I had an LED flashlight down here just a second ago. Look in the front of an LED flashlight. They're not one LED. They're like 8. These are great ways to get kids to realize like this electronic stuff is everywhere, right? So, I always am saving scraps of stuff to use in my classroom. I have a bin full of props. I buy things at garage sales, right? So they learn about what's an LED. That's your fundamental. Then they learn about the fact that the next step in the code, hey, you can change like LED brightness. You can make it fade. It's like, what? What's that? It's like, that's how smart light bulbs work. If you got a Philips Hue bulb at home and you can change how intense the brightness is, you can do that. What's that code look like? That code is just a series of number values. And it's actually, like a really simple concept to grasp. That's the project. Then we start blinking Morse code messages. That's the challenge that your advanced user is going to be like, oh, well, I already know a lot of this code. What should I be working on? We do these multi-layered things. When we learn about a click pushable button, which is in everything, TV remotes, the physical buttons on the side of your phone for volume, they're all what's called a switch, that it switches from high to low voltage or low to high voltage when you depress the button. We learn that basic concept. Then we just make a doorbell effect. Then we go and give students, the opportunity to make a musical jingle doorbell and actually have a speed control so that you can speed it up or slow it down and make it play different ways. You can see we go from a basic fundamental up to an application of it that allows your advanced users to thrive and also gives you as a first-time teacher something you can lean on whenever kids is like, why is this special? We don't want you to ever, feel like you're just showing students, well, it's an LED or, well, it's a button. Let's do something with it. Let's be excited about it, right? Because we want to inspire all levels of learners, right? Okay, so let's take a look at, well, I actually did the demos a little out of order. Forgive me, I go by how it feels when I present it. Sometimes my slides don't match me perfectly. So what were our goals today? We want to talk about Thimble Learners Experience, how to reach students with tech-based projects and supporting you on your journey. And normally, right, when we learn those kinds of things, those are objectives, you'd think of them as a linear thing, but they're actually simultaneous here. It's literally in how Thimble's built. The way we approach content, the way we approach our learners is all three. We want a meaningful experience for students that reaches them with tech-based projects and supports you on that journey of being that tech teacher, of being that computer science teacher, of being that engineering teacher. So our goals, I've given you all my objectives in one spot, and I'm actually a little ahead of schedule. So before we do our Q&A, I actually want to say anytime we do live presentations, this is another thing I think Thimble really is special in trying to do, is that if you're here, you've taken part out of your busy life. if you're a Thimble user in the future or not, this moment right now, this time that I have with you had better turn into something of value for you. So I'm going to talk to you about reaching kids, regardless if you use Thimble. Just want to help you for the next 8 minutes before we switch to Q&A, reaching kids. Whether it's Thimble or not, I want you to ask how to grow your skills reaching kids with technology, because it's important that every teacher right now, whether you're a tech teacher, an English teacher, social studies teacher, that you make these, I don't like the term digital native because I feel like it implied, like the kids who grew up with the internet who are now teachers, right? But how do you reach these students who tech is every aspect of their lives, right? Like I'm one of those teachers wearing a smartwatch. It's on my wrist all day, every day. Tech is everywhere. We should be using it. Like, I don't know if any of you have an Amazon Echo in your classroom that whenever a student asks something you don't know the answer, you say, guess what? We're going to ask the Amazon Echo, Alexa, what year was the Constitution signed? Whatever it is, right? Like if you aren't doing that and you have, the opportunity to put an Amazon Echo in your classroom, do it. How many of you are out there saying, all right, look at the clock, in 5 minutes, we're going to go ahead and, pass in our quizzes or whatever? No. Alexa, set a 5-minute timer. You should be using voice assistants in your classroom, but you want to show these students that education, school setting is no different than the rest of their lives, that it's just tech infused everywhere. And I want you to understand the culture of your students, because there's a story I want to tell you about a student who absolutely breaks my heart, because he has a home life that is not getting him where he needs to go. And I bet you have students like that too. We all have students like that you think, I would never want my child to feel that lost and lonely and helpless. And unfortunately, it's not always in control of those parents. I feel for those parents who've run out of money, who've run out of options, who are living with relatives, who are in many ways unable to change the course of their lives, right? So I had a student whose mom was a high school dropout, older brother was a high school dropout. They moved houses probably every 12 months, as they could probably not get a landlord who was going to keep them after 1 year, right? And he said to me, he goes, everyone tells me it gets better, but it didn't get better for anyone in my family. Why would it get better for me? This kid literally said this to me. Like, it's like knife in the heart when a kid says that to you, right? And you're thinking to yourself, like, well, I want to tell him, you're a teenager, when you're an adult, you'll be able to get through this tough part of life. That's not true, because he's looking around, he sees his mom is miserable, his brother's miserable, didn't get better for them. And it's like, can't give them promises that, aren't even mine to promise, right? And that kid did probably double the amount of work he did for me versus any other teacher. Is it because I'm a great teacher and I listened to him and I built a relationship with him and made sure that he felt, valued? No, I wouldn't say it was because of something special to me. It's because I'm the tech teacher. You have to see what these kids dream of. If you have a student like mine that, again, just telling you about him, I can feel like chills down my neck here, just thinking of him, what he's been through. These kids dream of a better life. They want to have their own house, their own car, to be able to afford groceries. They look at their parents, their siblings, the people in their lives, their aunts and uncles. I've had a student every year who breaks my heart. It's just, being a teacher, right? Their cultural influence tells them that tech is an opportunity, that they hear about these amazing jobs at Google and Apple. And I'm telling you, there's more than just Google and Apple. If you live, especially near a large city, go to a networking event for tech companies in that large city. You'll be blown away. Like, I found out that Pittsburgh had companies doing AI driverless car stuff. This was a number of years ago, right? Whenever that was first really, really coming interesting. And I was like, here in Pittsburgh, like not like Silicon Valley, California, right? Like here in Pittsburgh, that's happening. And it's like, it's eye-opening for you, right? That you as a teacher aren't coming from the tech industry to understand how many careers there are in this space. These kids, they idolize Steve Jobs and Bill Gates and Elon Musk and Peter Thiel, and these figures to them that are wealthy and successful, but they aren't greedy. they just don't want to have to, move houses every 12 months and, use public transit. They want to own a car. They want to have, or they don't want to have a car that's constantly breaking down or is constantly running out of gas. They just want to live, right? And they view tech as an opportunity. They view the ability to learn it while they're young as an opportunity. And so when you're reaching your students with tech, I want you to think about, it's not about the kid who already is great at computers. It's about the kid who is afraid to take a tech class because they don't want to fail, but wants to take a tech class because they want to succeed in life. And so I encourage you to look for those kids because they're the ones that slip through the cracks, right? And listen to them, right? And understand them and encourage them. And so if there's something you leave with today, and it's, a situation where, like I said, you've given your time to us, we want to leave you with at least something of value. I encourage you to reach your kids about tech. Maybe you don't know how to talk to them about how special it is to create technology, to learn tech skills. I want you to think about this. Okay, I tell my students, this is actually my opening pitch every year, is someone makes everything. The radio in your car, somebody had to make that. It didn't just materialize one day, right? The light that makes the camera flash in the back of your phone, somebody made that, figured that out, right? You logged in, you checked your email, somebody figured out how to make email communication a thing, right? All of that stuff, right? We live in a world of engineered products. You drive over a bridge, somebody designed it, right? Everything around us, people create. You can be that person who creates stuff. And so I try to inspire kids to see their everyday electronics, their cell phone, their game console, their tablet, television, they're all made by people. And the same things we teach at Thimble are things that are in everyday electronics. So I'm a big prop focused teacher. I want kids to see real things. I took apart a video game controller, I snapped this photo. These pieces, and I'm gonna go ahead and switch to my camera on the desk here in just a second, but these pieces are real examples of like the things that we teach with at Thimble, things we use in our projects, right? They are real things that are in everyday electronics. So in this game controller, which I'm gonna switch to my desk here in just a moment, I'm gonna really rip into it, are the same kinds of things that make Thimble projects. So I'm gonna point to that dice simulator that I had up earlier, and I'm gonna go ahead and pull in this game controller here. So I think I got all the pieces I wanna show you here. Let me switch out of this. I'm gonna stop the screen share. It's how I get kids excited about why you wanna learn to build tech stuff. So here is the set of parts that are part of this project. So this push button here, get this in your head, what this exact little push button is. This little square with a black dot in the center. Okay, from the side it looks like this. All right, here's a game controller. Okay, that is the exact same push button right there. Literally the same footprint. It has a little metal bar that when you click down on this controller, it pushes into that button. It's a 6 millimeter wide. It's a standard unit used in all kinds of electronics. Okay. These little membranes here actually are the same concept as a physical push button that has a tactile feedback, but instead of it having a loud click, because when I press this one, and you're not going to hear it over the built-in camera on my computer, but there's a louder tactile click here. These soft membranes are why video game controllers don't make your thumbs hurt. They also don't make loud clicky noises. Up here, where the shoulder buttons are, is another one of those membranes. There's another little trigger piece here. If you have an Xbox, they actually have those physical tactile buttons on certain parts in the top shoulders. This is a Nintendo game controller here. This part here, it's a slightly different frame. In the orange here, this is actually a dial that changes resistance as you tilt. You can't really see the rotation as much as I would like in the video feed, but there is a rotating dial here. This is great to like save busted game controllers and pull these little or PCBs out to have the components and have your students actually look at what's on them. That is the same functional piece as what is this spin dial in this thimble kit. That the pieces that make an analog joystick work are actually just two dials, one for X and one for Y. And as you rotate the joystick, it goes forward and back, just like spinning this little, it's going to do a trim potentiometer. It's basically a dial that changes resistance. So it changes the amount of current, electric current that can flow through, and it measures that. Regular everyday thing. We have a lot of products with Thimble that have sound effects. They come out of a little metal disc called a piezo buzzer, and it's inside of this little black housing here. You know, get a smoke detector at a yard sale, take the lid off. That's a piezo buzzer. It's a metal disc. It flexes when it gets hit with electric charge, and it vibrates. The things you build with thimble kits are in products everywhere. And an engineer works for, you know, a company that makes smoke detectors and does the work to design this PCB to make this enclosure, this plastic molded frame. An industrial engineer deals with how it gets assembled on a factory line. You know, someone who works in mechatronics possibly works in that factory, troubleshooting the machines if there's issues, right? There's just so many careers tied to just a smoke detector, tied to a video game controller. One of my favorite ones to show students is actually automatic nightlights, because they actually have, you can always find where the light sensitive part of it is, because it has to be visible so that it can tell. So this is a nightlight that goes on whenever, you know, it's dark, and there is the variable resistor, and you can touch it and it'll light up. Now, obviously it's not plugged in anything, but you can show students, you know, like, we'll just fool it, right? This is our light sensor in the Thimble kit. Same story, that make a light-based project, which we do one where you like make a thing that goes in a box, and when you lift the lid and the light hits it, it starts playing music. You know, you can cover it up and interact with it like a nightlight. Use real stuff. Get into collecting props. Get your students excited about seeing these things firsthand. You will wake them up, get them excited. So, all right, got a little long on my extra slides there, which I hope, you know, were worthwhile to get you excited about stuff. We'd love to hear from you. We'd love to answer any specific questions you have, or just connect with you, hear about, even if you just want to share something with the group here, maybe a message we talked about with trying to engage students. You have a thought you'd love to share with the other people in the audience. You know, let me go ahead and relink the June presentation for anybody who wasn't here at the beginning. I don't know how many of you started your school year up, and maybe you have an 11 o'clock, or maybe you already, you know, are running out of time and you need to relieve a sub or someone who's, you know, helping you out there. But if there's anything we can answer for you, feel welcome. Chat, microphone. I think you should be able to just hop on the mic. I don't even think you need to really formally ask permission. We're happy to welcome you. Is there anything we can answer for anybody? So, kind of surprised I haven't had any specific questions. Did I miss anything in the chat? Someone maybe asked about the class sessions. So yeah, I do see that, and thank you, Oscar, for answering that there. Here's what I would really love to talk about in regards to Thimble and the products we have here, because many of you, I'll go ahead and stop my camera share. Maybe you want to be able to see me, right? You know, because it's not fun to hear voice and look at slides. It's nice to actually see people, right? You know, I'm a firm believer in that. My students, I do teach online a lot, and I always make sure that I'm, you know, visible. So think of the things that you teach in, like, let's say computer science as a broad whole. Binary math, for example. What are zeros and ones? And if you don't know binary, you'd be amazed how many activity worksheets there are. It's part of AP Computer Science Principles. If you're a high school teacher, it's covered in Isaac Computer Science. If you don't know of Isaac Computer Science, it's a wealth of free resources for teaching computer science, cross concepts like what's binary, what's hexadecimal, watercolor values, things like that, right? If you're already teaching those kinds of things, right, Thimble's a way to add in a hands-on component, right? So if you teach, let's say, a Thimble project, so fundamental through project through challenge every week, you'll get about 18 good weeks, I would say, of content. We really shoot for that kind of like half-year structure where you'll still be able to then tangent into other topics, right? So when we've had it as an after-school program at schools, it's half a year, 2 days a week. So think of it in those terms, that you want to have other, like you would fit this into your tech elective, right? So my tech elective in my school is coding and design. So we do coding activities, we do 3D printing activities, and literally we just have days that are literally not based off of physical device. This is physical computing, where we talk about how websites work, how the internet works, right? That's a big topic. If you aren't teaching how the internet works to your students, please do, because it will blow their minds, because they don't understand, because they've grown up with it, what many of us who maybe, learned it in even elementary or middle school, right, about the idea of what's a hypertext transfer protocol, HTTP, hypertext markup language, HTML, that, whenever you type in a web address, that it actually points to a domain name server that resolves that name, like google.com, into a numeric IP address, internet protocol that, finds the device, generates what's going to send back to them, and transfers it back to them, and loads your web page. Like that's something that I teach in addition to using Thimble, physical computing, type of resources, right? So if you are using this in your class, my recommendation is to remember that, like you don't just throw out all the things that you are teaching and just replace it with physical computing. You want to be, all of those pieces. As far as grade level goes, let's see that, we've got a great question there. What is the most responsive and engaged with the courses? You go too young, you're going to run into issues with the math concepts. So I'm always in favor of a lot of other products out there in the world, right? You're never going to hear me tell you don't use code.org, because you should use code.org. If you're using Thimble and you're using code.org, you're building a great ecosystem of resources, right? But one of the problems that I run into a lot is that a lot of the younger grade level stuff that I see by other vendors, right? And this is why we don't, try to market doing Arduino and physical computing with kids that are, 8 years old, right? My son's turning 5 this month. And if you asked me, like, when is he going to start learning coding? It's like, well, there's a certain threshold cognitively that if you teach it too early, you're going to mess up their ability to do basic math. What do I mean by that? When I say x equals 5 in code, I make a variable called x and I assign it a value. That's different than me saying x equals, 5 plus 2, solve for x. Solving for x and assigning a variable in code are two different things. You do it at the wrong time, and you're actually going to make it harder for kids. Functions, for example, in function notation, so f of x, which you maybe, if you're a math teacher, you're familiar with teaching function notation, right? We don't start kids with function notation, right? Because the concept behind f of x is really, think of it like having an x and y graph, right? So for every value of x, like where there's a value that this resolves to. So f of x equals x plus 1. So when x is 1, y is 2, basically, right? That we're able to resolve that equation for every value of x. That's in code, right? If you show that to a kid who's still learning basic arithmetic, you're going to give them a meltdown, right? So you have to view where it's developmentally appropriate. The higher grade level that you dive into physical computing, the deeper you can go in the code side of things. But as far as accessibility on what is electronics, I show my son about basic electrical concepts I've been showing him since he was 2. So you have to understand there's a very specific difference between like, what are LEDs, what's a motor, what's, electricity, right? And like, let's create a recursive function in code, which if anybody here is a big coder, they're gonna be like, yeah, you're not gonna teach a 5-year-old about recursion. But like my son can tell you how a 3D printer works. Actually, my son's now coming down the steps. I think he wants to come and find me. Hey buddy, I'll be up in a bit. Okay. I'm still teaching, buddy. I'm sorry. If you want to wave to everybody, you can come on down. So you get to meet my son, James. Go ahead, buddy. Come on down. And again, like, he learns about tech stuff all the time. Hey buddy, I see you got a sock on your hand. Daddy's talking to teachers in New York State, and he was telling them how we spent some time learning about different electronics. Have you ever seen Play-Doh that works like a thing that you can tap and talk to a circuit thing? No. You always want me to build the Play-Doh circuit. When Daddy brings out his Play-Doh and we can tap on it and the thing lights up.
Okay.
All right, so he's gonna make me seem like I don't actually do these things, and he's gonna go into, hey buddy, leave the closet shut. Dad's got his. That's where Dad's Play-Doh is. Now we're not gonna build it right now, buddy. But I show my son basic, like, so that's a conductive activity that I do with him, is when you tap on it, it actually conducts and can detect the touch. So anyways, teach young kids electricity, right? Teach them core concepts. As they mature, introduce code. 3rd grade's a great starting point to get your basics coding wise. By the time you're in middle school, you can start doing those complex things. High schoolers, biggest thing for high schoolers, and I can't stress this enough, I teach middle and high schoolers all the time, right? I'm always working middle and high schoolers. High schoolers, you have got to get them to start focusing on the design thinking process and to get them to generate code, literally create original projects. That's just the future of this stuff. So that's my recommendation for all of you. And as you can see, I got my wife retrieving my son, and I told him I'd be done at 11, and so he's very eager to see me. But I think Aaron gives a great comment here about more exposure, less barriers. I think we're going to wrap it up there. I don't think I missed any other questions. Please reach out to us. We are always happy to reply to an email, schedule, product demo if you need more information. We're thrilled that you joined us today. Like I said, whether you become a Thimble educator, work with our products, or if you are just here just to learn, I hope you got something exciting to take with you today. And thank you so much for your time, everyone.
Thanks, everyone.